What we are trying to show here is just the whole value chain of how the heap fits into the whole process. So what happens is that we start with what we call the powder, which is the stainless steel. It's produced within CSIR as well. We managed to produce this via ultrasonic atomizer. So what we did when the commissioning of the heap was completed, we then decided to do a sort of like a project that actually is a baseline to show how do we improve on our property. So we took some of the materials, which is the metal matrix materials that we had casted within in CSIR, and we heap them. After that, we then go and make a mechanical testing. So that actually gives you a process of saying from one point to the other, is there any improvement or not? So what we have seen then, because we have the unheaped and the heaped one, what we've seen that from the unheaped one, there is a certain number, there's a certain tensile properties. Okay. And then from the heaped one, then you get a higher value, okay, which shows that actually the heap itself gives you a higher integrity of the material because it closes the pores and any possible defects. And then what we have here, which is a very interesting one, is actually from MMS, who are here today as well. So what they do is that they do a casing of that. So this casing actually, it depends on the shape inside. So they create a shape and then they put a powder and then we heap it at a certain temperature and pressure. So when they cut this casing out, actually that powder comes out as a solid material or a solid component of that shape that actually they've put in this casing. So it comes as a near net shape component. So that's what this heap is all about from MMS point. And also we did some work for BMW, which is this one. We also did the same thing. Do the non-destructive testing first, then you do the heaping. After you go back to the non-destructive just to check if you have closed the pores that you had, and then from there you take it to the mechanical testing. And then the feedback actually that we sent to BMW, the report that we sent was to say actually we saw an improvement in your properties as far as mechanical properties of these samples is concerned. So what is the next step that we need to do now is to actually expose ourselves to the most industry to say this facility does work, because this was the baseline. Yes. So we've achieved what we wanted to achieve on a baseline. Now we can move on to the industry as it is. So this actually I can say this is from University of Johannesburg. Okay. We're also doing the same. They want also to develop a profile. So the main idea that we have at a research foundation is to say that we develop a profile for each and every material and for each and every process. For example, for casting, if you're casting aluminium, what exactly you are looking for, and then what is it that you look for the improvement. And you have that profile to say, if you cast at these parameters and you heap at these parameters, then this is what you're going to get. Same as the 3D printing, which is the what's called additive manufacturing. We do the same. So for each and every process that is available that we can be able to involve ourselves, then we develop those profiles. So when you come with your component next time, we say, what material is this? This is aluminium, and then which process did you use to produce this component? To say this is the process. Then we know exactly what type of parameters we need to use from the heap. That's the most fundamental thing that we need to do. And then after that, the only thing that is left now for us is to go out there and look for industries that needs this, because we've already developed the process. Thank you.